Hey guys, welcome back to the shop. Today I got some fabrication to do, so there's going to be some welding, measuring, AutoCAD work, and then plasma cutting. And what I'm working on is the front blade off of a mini excavator. The blade on these mini excavators, they are made with about $5 in metal. They are garbage for what they cost. They're basically sheet metal. I got the busted one outside. I'll take the camera out there and I'll show you. Okay, here's the blade. You can see I've got the wiper blade already cut off, or the bolts were off. It was worn down. I had to cut all the bolts because the bolts were rubbing the floor. But you see, this thing is just sheet metal. It's got a 3/16 blade, and this is all 10 gauge here on the back to make the body of it. So really, there's no gussets. They just box it in to give it strength. I've already got the end pieces all torched off, cleaned up. But that's where it just ripped right off. And you got the plate, 1/4 inch, and 3/8 plate down on the bottom. That's what we got to dig out of there to make all the gussets. Here's the frame. I'll get it out of the truck here and look at it. But just ripped it right off. Okay, what we're going to do is I'm going to set this up on here on my fab table, and I already took measurements off of the machine, so I'm going to set it at its height where it's pinned into the machine, which is 7.5 inches from the table up to the bottom of that tube is 7.5 inches. I'll get it level, then I'll bring the blade over, which I'll show you here in a second, and we'll set that up and clamp that down, and then I basically got to marry the two together with gussets and brackets that I'll need to make out on the plasma table. Okay, here's the new blade. I had a local shop bend it all. Their roll wasn't wide enough to go over 6 feet, so this is just a series of breaks, and this is 3/8 thick, and I've already got all the end plates tacked onto it, and so I just basically got to put the two together and hold them up there and take a bunch of measurements and do some CAD work and make brackets to connect the two. I got all that cut off. Oh crap, down here. But I still got to get the plates off, but I'm going to take the grinder and clean off all the old welds. I'm going to leave these gussets on just for a reference where I know that top of the blade has to be. And like I said, get this cleaned up. These plates here on the end cut off because that's part of the blade. Get rid of those. I'll have to flip it over and cut the bottom yet, and then get this side cleaned up. So I'm going to do all the grinding first and flip it over, peel those pieces off, clean that up, and we'll get it moved inside. Alright, I got them all cut off, and those gussets that were on the side here, those were just 10 gauge. So I cut them off because I'm not going to weld any 3/8 plate to 10 gauge, and these tubes here are only 1/4 inch. It looks like about a 6x3 tube. So, and this pipe that's pretty heavy. I mean, I can pick that up, but I don't want to walk with it. This thing damn near a couple 100 pounds. Alright, so now I'm going to need to get this cribbed up, get it level, and up 7.5 inches from the table to the bottom of the tube. Well, I got it set up here kind of how I want it. Sorry, the light from the door blowing it out a little. I've got it cribbed up where it needs to be. It's not on the strap. It's up in here, setting on the brackets, the original brackets. And I'm basically taking a guess at the pitch of where this is when it's level. So when it comes down, because this at damn air compressor. There it is. I got it up 7.5 inches. I know these blocks here are 6 inches, and then I have a 1, 2, 3 block underneath of it sitting on the. Luckily, this bracket is a 1/2 inch offset, so it's sitting on there. So it's like they're both the same, and it's close enough to 7.5. I mean, it's real close. And then I set this side here at the same height. It's sitting on 3 points, sitting on a 1, 2, 3 block right there in the center of that round tube. So it's sitting on 3 points. It's pretty decent. And then I brought the blade up, set it on the brackets, and started playing around with pitch angles. So when this is down, it cups over. So the blade will be almost, it should be around 10 or so degrees with the floor, and then this will, you know what I mean, it'll come out and over. I was looking at a few pictures. I'm just taking a guess on it. I'm sure it'll work, and I'm sure it'll be fine. But I got this piece of strap in here as a straight edge from here to, there all the way across. It's straight, so I got something to measure off of from here to here. Already ran a straight edge across to it and put a mark. Now I'm going to make a plate that's going to come back here and weld underneath, and then come over to here. It's going to basically box all this in, and that'll stiffen all that up. Yep. So the plate that I'm doing, it's basically going to go like that. This is the blade out here, and there's the square tubes right here, and that's how much offset it is. It's like 2 inches. That's 5 inch. From here to here is 5 inch, and then 2 inches back here from here to here. I mean, that 2 inches would be fine, because I'm still going to make a gusset plate that's going to weld on from here and go up. It's basically going to follow the contour here. It's going to follow this contour here and go up all the way up underneath here, and it'll be one big gusset for pushing. And then this plate here will keep it from bowing. Along with this be the rigid for the top, and then the plate I weld in will be the rigid for the bottom, and then the gussets to connect the blade to the tubes. So I'll get that laid down. I'll get this all done in AutoCAD and get the 3/8 plate up on the burn table, and we're gonna cut that out. Alright, this is real simple, just 4 sides, and save it as a DXF and then convert it over to G-code. So what we'll do first, I guess basically start with a line. I need to turn my ortho on. So I had 72 and 1/16. So there's that line. Now I know it's going to be 7 inches at the widest point. So I'll just put that dummy line in there for now, and then I got another line to do that's 25.5. And I can dimension that to make sure I just push the right buttons. Done that before. Yep, 25.5. And then I'll snap this up to the 7-inch line. Now that can go away. And then I basically this got to come down 5 inches. Repeat line, 5 inches, and then I can connect the dots. Repeat line. Simple as that, right? I'm going to make, because of the welds and stuff, I don't want a sharp corner. So I'm going to modify, and where to go? There it is, fillet. And I push R for radius, enter, and probably do a 3/8 radius. Click that. That and that. Create the radiuses in the corners, just so you don't have to grind them. I could probably even do it for here too, just for the weldlet. Oops. There. Shouldn't need anything there. That should transition pretty good with the torch. But you always round all your corners, like when you're plasma cutting, you know, stuff. You can even make, see, a 90-degree turn causes your torch to stop. I mean, you could go all the way down. If you don't want the radius, or one you can notice or see, you can put in a 1/32 radius. It just doesn't let the torch stop. So you got crisper corners. But being a torch, or being a plasma, it's, I don't know. I mean, I've done it both ways with a sharp turn, you know, straight 90, and then I've radiused them also, and sometimes it doesn't matter just because the torch happened to stop, so it blows out a little extra metal. But if you did want a crisp line, or in the programming of the when I put it into sheet cam, I could set the torch to be coming along this way, and then it'll go past and it'll arc up this way and then come back into the cut and go down that way. That's the only way that you can get a true sharp corner on a plate. But I've never had to do that, because anything I do, it's usually a welded corner anyway, so I'm not even saying that I won't be hitting that with a grinder or anything, you know, but 3/8 radius should clear any existing welds that are on that. But all right, what I do then is I save as, we'll name it, and then I'll open up my sheet cam. And then I will import a drawing. I want to go to my documents, up here to CWE. Blade gusset lower. And then this program I've already had it. It auto goes where you originally set it up. So have it set right here. It'll go down and it'll start in the bottom of the sheet right here. So it's gonna, but it's 6, I think it's under 6 feet. Yeah, so I can't turn it. Okay. So see, there it is right there in the corner of the sheet. I'm gonna move it just a little bit off of the edges of the sheet. Yeah, I don't know if you saw it or not, but I moved it. So when I I put my torch right dead in the corner, so that gives me a little offset, so that's good. Then I'm going to go over here to operation, plasma cut, and it already has it layered for me. That's just one cut line. 3/8 steel. I got a lead in and a lead out of 150 thousandths, which should be fine. I really don't need that much lead out, but it'll be fine. You don't have to worry about none of this. You don't have to worry about none of this. Path rules, stuff like that. You don't need, if you're plasma cutting, you don't need any of that. There are some path rules you can put in it, like when you go to cutting holes, because like the sheet, it wants to run at 18 inches a minute with 3/8 plate. But you can also put in a path rule. If it goes to a hole, you can slow the torch down to 10 inches per minute, 8 inches per minute when you cut the hole, so you can get a straighter, better cut. But my hypotherm, it's pretty good on holes, so I don't worry about it. And any holes that I need are basically an oversized hole for a bolt anyway, so I haven't had to do anything. Of course, this thing doesn't really do anything precision. I mean, it's just really close, It's like if I cut this out and measured it, if I cut it out and measured it, I'd be dead nuts square, but then it might be a 30-second shorter than my overall measurements, maybe. It is going to cut on the outside of the line. So you can see my lead in and lead out over here. And I can actually move that lead in, which I probably will, because I don't need that $150,000 or 150 thousandths cut out into good material. I can go up here to edit start points, and then I can move it over here. I can move it right there under that scrap piece. So now it'll lead in right here and go on up this way. So now I go over here to post processor, and you can change the name of it or keep the same name, and this is the G-code to tap code where it'll save it, and I save all those on my desktop. That way I can delete them or put them in another file to save them for if I ever think I'm going to need it again, which this is a one-time deal here. So, and Didn't have any problems. Usually when you have problems, all these letters, the post processor will be red and it'll tell you what's wrong. If you have cross lines or if you have a broken line or something like that. But SheetCam is really good about taking out double lines and stuff like that. It'll tell you if it had any, and it'll delete them. And then hit OK, and there I got my G-code now. Oh, okay. I'll fire up the Mach 3. I'm using the UC100 motion controller. That way, that's what lets me use my laptop in Windows 10. It's basically faking the controller. I have the Gecko 540, I believe, controller. See, now what I'll do is I'll take the torch and put it wherever I need to on the sheet. I don't have the sheet in here yet, and then you just basically zero out all your axis where you want it to start, and then you load your G-code, and that's on my desktop. So, and right there, I usually go past it 5 times before I get to it, but there's the G-code. It's like 380 lines of code, maybe. Something like that. Here it is over here. Go over here to the toolpaths and a little stronger picture of it. I go back here, and then basically then you just hit the start and let her rip. So I'll bring you back here in a few. I got to get the plate moved in here and get it up on the table, and then re-zero out all this. So basically I'll just close that G-code out, and then that lets me move the torch now. So I control that off my keyboard, and then I also could control it off of this wireless pendant. So I'll bring you back here in a few. Moving that around with the board. I had 2 pieces of steel that I used for a stopper, and I put this up because of when I set up the program, and then I got an old video where I made that track, extended it, so this will actually move another 4 inches. I got actually the consumable, or the cup is hanging over the plate a little, just because I'm guesstimating the center of that tip being as close as I can to the edge of the sheet. That way it just eliminates a lot of scrap. There's my zeros, and then I'll go up here and load G-code. Blade gusset, and she should be ready to fire off. Man, that's a nice cut. Awful heavy. A little bit of dross on it, but it's not too bad. I'll let that cooling fan and that shut off for them. It'll probably take about 2-3 minutes, so I'll bring it back and look at this plate and try to get it fitted in over here.